Welcome back, PlayBASIC coders. Let's take a look at the ray tracer. This is a demonstration of the built-in intersection libraries, the math libraries now. So this is the classic. Ray tracer. Just in other words, for every object in the scene, we're throwing a ray out for every pixel. At that intersection point, then we're computing a new ray back to the light to see if it's in shadow. So clearly, the more objects you add, the slower things get. There's 4 objects in the scene here. We're standing on top of a big sphere plus the 3 spheres here. We've added a camera look thing as well. The main change to this is a PVS, potential visibility set. So we convert the render into here, get some extra performance for nowhere. It doesn't really help us with small numbers of objects. There's an overlap here so we're cutting the screen up into regions and going what objects are inside those regions, and then doing ray intersections against the short lists of that. Move the camera up a bit, move it back out a bit, and let's add a few objects. Unfortunately, the scene's randomized every time you hit add, but you get the idea. So we've got 300 objects there with shadows as well. Clearly, it's way too much work for an interpreted BASIC to do. That's why we're running in a small resolution to begin with. But we're still actually we're able to run at a handful of frames per second. If I switch back to classic mode now, see up the top here, method classic, we're seconds between refreshes. So we've gone from a refresh a couple of times a second to probably an order of magnitude slower. Look, I used the same basic idea in Visible Worlds years ago. The idea was to try and eliminate potential colliders with ray intersections. I mean, Visible Worlds is pretty much just it's basically a light mapper. It runs through the world from every possible standing location and runs ray intersections against everything in the world. That's why it has to reduce the number of objects you're comparing against to try and make that, not take 3 years to complete. That was written 25 years ago or something. I'm pretty happy with that. You mightn't think much of that, but that's of course we're not talking about hardware accelerator. This is all software running through the PlayBASIC interpreter of all things. So on my laptop. Now it's a simple ray trace scene, fair enough, but those who understand that know how much work it requires to compute each pixel, and there's a lot. Like even if you take a look at this part over here on this map, it's hard to read, but it gives us an indication of how many spheres overlap each section. So when we look in directions where there's lots of things in front of us, we still have lots of ray intersections to run to work out the closest object to the camera. Like looking through here is doing heaps of intersections against objects behind that, let alone the ground over here. And we've got shadows as well. So if we turn shadows off, it's much easier for it to render. The shadows, I'm doing much the same thing. I'm computing a list of things between the object and the light, and if I've got a short list of objects that potentially collide us between each object and each light in the scene. There's only one light, so it's no big deal. Where's our setup? This turns off shadow casting, so we shouldn't get casting for objects as we rebuild the world. Try it again. Move the camera up again. Like with 3 objects, it's pretty fast for just classic ray trace. Turn PVS on, no shadows. Start bumping up the object count. Not having a shadow means that we don't have to work out how lit the pixel is. We don't have reflections as well. I mean, reflections would kill this completely. So, but you know, it's pretty interesting. So 470 objects are inside the object there. I don't know how far we can push it. I think it's 1,000 the peak. So we'll try and push up towards a few hundred. 700 objects. This kind of potential visibility set optimization, look, it's a very common one in 3D. We use it in 2D as well, by the way. It just gives us a short list of things that we might be impacting. Yeah, it's clamped to 1,000. I'm actually I'm amazed that that's even running as well as what it is there. I thought it would just be a slideshow by now. You might think it is a slideshow, but I'm pretty impressed with that. Again, it's just an interpreted BASIC with a math library. And the math library is handling the ray to sphere intersections, by the way. But most of the calculation is done inside PV. It's not perfect, it's not brilliant, but gives you an indication of what you can achieve with a bit of lateral thinking. I'll switch it back to normal mode. We'll see how long it takes to render a frame. This has got shadows with it though, so that will be slower anyway. I mean, the best part about this is it's not taking minutes to render the frame. You know, if we bump the resolution up to native resolution, it probably would take minutes, you know. But yeah, it's a cool tech demo. Alrighty, thanks for watching. I'll see you next time. Bye.